Hey kids, today we are going to be looking at algebraic expressions. We can use what we know about numerical expressions to help us with algebraic expressions. The difference between the two is that numerical expression has numbers and operation signs without the equal signs, and the algebraic expressions has the numbers, operation signs, and at least one variable. And a variable is a symbol or a letter that stands for a number or a group of numbers that we are trying to solve for. These are our unknowns. All of these are examples of ways that variables can be written within an algebraic expression. If we look at our first example and unlock the problem, we're going to write an algebraic expression that matches the model that we are given here. This is going to be an addition model, and our directions say let this tile represent 1, and hexagon represent an unknown number. So our tile is going to represent 1, and our hexagon is going to represent an unknown number. I'm keeping in mind this word and. Usually that means we're going to join some equal groups not equal groups, but join a group or groups together in order to add them. So we're going to join these groups. So the tiles joined to the hexagon will complete my algebraic expression. This is my unknown. Each tile represents the digit 1. So if we put the digit 1 in each tile and we go back and we count them all, we will see that there are 8 here total. And so when I'm looking at my algebraic expression, this would be 8 plus a number. As I don't know what that number is, my hexagon represents an unknown, so I would simply have 8 plus a number. And I would write it like this, 8 plus a number. And that symbol that's here is my hexagon. And then when I write the mathematical symbols for that, 8 plus a number, I'm going to write it like this, 8 plus the hexagon. In my multiplication example, I am going to let the hexagon represent the unknown. Okay, so all these hexagons represent the unknown. And there are 4 hexagons. So I can see that there are 4 of those hexagons. So my words are going to say 4 times a number, because I don't know what the number is. I just know that there's 4 of that set of numbers. So I'm going to write my words as 4 times a number. Now, notice here that there is a variable written because I can choose any variable that I want to place here. So for my unknowns, I can choose the variable n. I can do that. And then I would write my mathematical symbols as 4 times n. Now, I can write n in many different ways. When we're showing 4 times n, multiplication algebraic expression can be written in several different ways. And here are the ways that they can be written. We can have 4 times n, so I can use the multiplication sign. I can use a dot, 4 times n. It means the same thing as multiplying in the middle between the variable and the actual number. I can put the variable in parentheses, or I can simply put the variable next to my number and have 4n, and all of those mean multiplication. Let's look at our division model. Our division model shows that the entire model represents the variable y. The entire model is y. This is our unknown. We don't know what number is. And y, this model y, is divided into 1, 2, 3, 4 sections. Okay? So I'm going to have y, the whole thing is y, divided into 4 sections. So y divided by 4. Y would be a number divided by 4, because I don't know what that number is. And I need to put y in my word so that the person, my reader, knows that I'm clearly identifying what the y is. A number y divided by 4. Okay? So the y represents just a number. We don't know what that is. And when I write my division, I would simply write y divided by 4, which says a number divided by 4. When I'm looking at subtraction, I have to look at, again, this entire model. So I'm starting at the 0, I'm going all the way to the end. The J tells me that the entire model is J. And I know that when I'm counting backwards on the number line, I'm going to be subtracting or dividing. In this case, we're subtracting. We're subtracting 4. So when we're looking at what our words would say, our unknown would be J. So that's our number that's unknown. And we would write it this way: 4 less than a number. So 4 less than a number. J represents a number. We don't know what number that is. So 4 less than the number J. And then when I write subtraction as a symbol, I need to use my subtraction sign. And then I would write J minus 4. And the 4 comes second. You have to look at that. The 4 comes second because 4 is less than J. If we wrote it the other way around, 4 minus J, that would say J less than 4. And that's not what this model represents. So we have to be careful about that. Let's look at another example. We're going to model and write an expression to match these words. Cow buys a ticket to the water park. Kylie buys a ticket to the water park. She spends $6 for lunch. How much does Kylie spend for a ticket and lunch? So this is about Kylie going to the water park. And we're trying to figure out how much does she spend for a ticket and lunch. Remember that. And the information that we need, we know that she spends $6 for lunch. So she buys a ticket. How much money does she spend for the ticket and lunch? Well, we want to let P represent the price of the ticket. So they're telling us what variable we're going to use. P is the variable that we're going to use to represent the price of the ticket. So she buys a ticket. So P is the ticket because we do not know the number. That's our unknown. P is the ticket. So we need to make a model to show that we're going to join equal groups. And remember, we're probably going to be adding, so we're going to be join equal groups. So my model will simply look like this. I can take make this model take a rectangle, and then I need to divide the rectangle into 2 equal parts. It's close to two parts. And then I am going to join the P, okay, with how much she spent on lunch. So we will have P over here and 6 over here. And this is my addition model, P plus 6. We join those two together. And when I'm looking at what words and symbols I am going to use, so we know that one side is going to represent the number of tickets, and the other side is going to represent how much she spent on lunch. So it says, how much does Kylie spend for a ticket and lunch? So we know she spends $6 for lunch, but we don't know how much she spends for the ticket. So we want to combine the ticket and lunch. One side is going to be the ticket, the other side is going to be a lunch, and we know that we're adding this together. So to look at what that would be, if I unveil this, we would see that what we're going to do is put the price of the ticket over here, and the price of the ticket is going to be P for price of the ticket, plus the money spent for lunch is going to be $6. That's how much she spent on lunch, and that's what we would put here, be $6. And this would be also showing that this is $6 showing money. So that's the model that we would use to match these words. If I'm looking at the next example, Daniel sees some dolphins while he's at the water park. He sees 8 times as many turtles as dolphins. How many turtles does he see? Let D represent the number of dolphins he sees. That's the expression that we're looking for the number of dolphins. So Daniel was at the water park, and he's going to see some dolphins and turtles. But specifically, he's going to see 8 times as many. That word times lets me know something. Okay, when I am looking at a word problem, I'm probably going to be doing some multiplication. And so what we will have is our rectangle, and we would take the rectangle and we would split it into 8 equal parts. That's what we would do with this. 1, 2, 3, 4, 5, 6, 7, 8. And D is going to represent the number of dolphins he sees. Remember, he sees 8 times as many turtles as dolphins. So how many turtles, we're looking for how many turtles does Daniel see. So if he sees 8 times as many turtles as dolphins, we want to know how many turtles does he see. D is going to represent the number of dolphins he sees. So D is for dolphins. And so we're going to put the D's inside of each of these to represent the dolphins. So each box get a D, and then we will look at what our symbols and our words would look like what we're gonna put over here, and we would write words and symbols. So we would have here. Let's see, where did I? Okay. 8 times D would be our symbols, and then our words we would put. We're gonna 8 would go here, and then over here times a number. Okay, and that would be the 8 times a number. So he saw 8 times as many. Okay, and that's how we would do that. Now, I want you to look at the next 2 examples, and I want you to figure out how you would put in the expression to match the words, and try to figure out what the expressions represent in both of these cases. Okay, so up here, this expression 8 times a number represents the number of dolphins that he saw. So we want to make sure that you're looking at the expression and making sure they match the words. Up here, this expression simply lets us know that a number of tickets plus $6 is going to tell me how much total was spent on the tickets and on lunch. So that's what that is saying. So make sure you remember to look in your journal. Remember to make sure you finish your whisk and go onto Edmodo and let me know you watched the video, and complete any other things that you're required to do through Edmodo. Please read the directions and check for that. See you guys in class.